In this video, we're going to explain sectors and arcs. So a sector or an arc is a fraction of the circle. So if you have a circle like that, when we're talking about a sector, so it's, let's say I want to find the area of this shaded part, which is part or a fraction of the total area of the circle. So what is this fraction? Is it quarter? Is it less? And so on. How do I know? I know from this angle. And knowing that the total angles of a circle is 360 degrees. So I look at the angle facing this sector and see how much is it from the 360 degrees. So this gives you, so if you want the area of the sector, so you look at the angle and see how much is it from the 360 degrees. And then this gives you the fraction of the area. But this is not yet the area unless you multiply it by the total area of the circle. And the total area of the circle is pi r squared. So this is a part of the area of the circle, and the part is defined by the fraction, which looks at the angle, how much is it from the 360 degrees. Same thing, if I'm talking about the arc, so I'm talking about this part over here, right? So again, this is a part of the total circumference of the circle, which is the 2 pi r. So what fraction of this? Again, I look at the angle facing this arc. So we call this the length of the arc. And I just look at, again, the angle, how much is it from the 360 degrees. But this time I'm going to multiply it by the total length of the circle, which is 2 pi r. So let's take an example of this. If you have a circle that has this to be 60 degrees and the radius, let's say, is 5. So what is the area of this part? Where the area of this part is going to be 60 divided by 360. This is the fraction multiplied by the total area of the circle, which is going to be pi multiplied by 5 squared. If I want the length of the external arc outside this part, then the length is going to be 60 over 360 again, which could be simplified to 1 over 6. And then you multiply it by the total circumference of the circle, which is 2 times pi times 5. Notice that you have 3 things that can change in your equation, either the radius, the angle, or the area, if I'm talking about the area, or the radius, the angle, and the length, if you're talking about the length. So it's not always that he wants the area or the length. He might give you the area and ask for the radius, or he might give you the length and ask for the angle. So let's take examples on this. So suppose that you have a circle like that, and I gave you that the area of this circle is actually 12 pi. And I gave you that the angle is, let's say, 40 degrees, and you want to find the radius. So now in this case, the radius is the unknown. So knowing that you have the area, so you know you are going to use the rule for the area. So let's write this again, x over 360 multiplied by pi r squared. Now just write in what you have. You actually have the area of the sector, so you put here 12 pi. You have the angle, so you put here 40 divided by 360, and you just want to solve for the radius. So solving for the radius, you just need to rearrange this equation. You can cancel the pi with the pi. You can simplify this, so this becomes 1 over 9 by dividing by 4 up and down, multiplied by r squared. This is equal to 12. So r squared is equal to 9 multiplied by 12. You move 9 here with the multiplication, and this is going to give you 108. So the radius is going to be the square root of 108. So this is the case where you have the angle and the area, and you just want the radius. So you use the same rule, but you just rearrange the equation in order to find your radius.